Hello everybody. Once again, welcome to Intro to GIS. We are starting with our Chapter 1 presentation in this slideshow. And just in case you need a review, it's Geography 1100, Fall 2019. So let's go ahead and get started and move into the content. So as this is the first chapter, of course, we're doing a lot of introductory information. So let's start with the basics. Let's talk about what is GIS. Sometimes you'll also hear people call it AGIS. That's because GIS is actually a generic term for what this computerized version of mapping does. So you should all know what it stands for, Geographic Information Systems. But what does that mean exactly? Well, the definition I picked out says a system designed to capture, store, manipulate, analyze, manage, and present all types of geographical data. The key word to this technology is geography. This means that some portion of the data is spatial, and in other words, data that is some way referenced to locations on Earth. So this has a lot of meaning to it, and we're going to kind of dissect it as we go through these next slides, because the idea of geospatial data is very important and at the center of what makes a GIS work. So ultimately it's about geography. We have the word geospatial. The root of that also is related to geography. But what is geography exactly? Well, it's why things are where they are. And that can include people, which is individual or group, or people grouped according to a variety of characteristics, such as demographic data or census data. It can be places, a mountain, a river, a region, a building, a city, a country, anything that is a place, anything that has either a geographic feature or a landmark attached to it. Or it can be a phenomenon. It can be things that happen to these people and places, such as rain, snow, disease, flooding, war, weather, a variety of characteristics. And just to add to this little thing about the geography and about why things are where they are, elemental to this is what is called GIST, Geographic Information Science Technology, which is the equipment basically that generates all of this massive amount of geospatial data we now have out there. And there's actually a whole class dedicated to this. I'm sure, I think most of you have either taken it or are taking it. So you'll learn a lot more about what is involved in the technology that goes into creating this geospatial data. So really it's about location, 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 location. So all of these things, these people, these places, the phenomenon, it's all about, it all becomes important because it has a specific coordinate tied to it. This is called geospatial data. This kind of data can be a single point, it can have boundaries, it can be a line, it can even change over time, which is called continuous data. These features are always connected to a known location on the Earth's surface. And what adds another extra turn to it and what makes it more valuable is the non-geospatial data, which is also known as attribute data. And it's the why behind the where in the definition of geography. We'll go more into what attribute data is, but let's just, I'll give you a preview just to say that attribute data describes the geospatial data. So we'll have a point, let's say, is a house on a map, but the attribute data for that point will tell us who lives in that house. How long have they lived there? What kind of house is it? How many bedrooms does it have? So these are all attributes of that point, but that can't be mapped. But at the same time, they actually can be analyzed. Okay, more on that later. So what is a GIS? Well, essentially it is map making or maps in general. And when you look at it that way, maps have been around for millennia, thousands and thousands of years. I've used this slide before and I actually switched it out this morning, this picture here. I don't know if there's a highlighter showing up. I think there is. On the left side here, I thought this was fascinating. It's called the Abons La Mizulo rock map from Navarre, Spain, circa 14,000 BC. And I just thought it was really cool because, of course, it's showing, at least according to the person who had found it and interpreted it, which I will trust their interpretation, we have a river, we have the different kinds of caves, a mountain, we have where the animals can be found in relation to these things. So it is a map, and it is about somebody 14,000 years ago describing where to find these certain things based upon geophysical characteristics. But it got even more official. We have this Babylonian map of the world. It's circa 600 BCE, which shows a very kind of rudimentary map of the world, envisioning Babylon. Babylon is the center of the kingdom, and then things coming out from it. This one I think is interesting because it shows a little bit more about how maps can be used to describe one's political leanings, such as this one of done by a Korean. It's from Korea. Korea is actually here on the right. This is China, and then this is Europe over here, this tiny little thing, and then that's Africa. So it just gives you an idea of how important they felt they were, Korea, because, you know, relatively speaking, Korea is not bigger than Africa, but that's what it looks like on the map. So those are like the flat maps that we see, the maps that are very open to interpretation. And we move down forward through history where we start to get more technology at play, things that can measure latitude and longitude, telescopes, things that we can actually use to start measuring the sun and time. And we come up with things like datums and geographic coordinate systems, which is where we get our latitude and longitude, or projected coordinate systems. Now again, my picture is hiding this picture here, but it's actually a projected coordinate system. It's in the shape of a heart. That is one of the projected coordinate systems, and I can't remember the name of it, but projected coordinate systems will show the map of the world in a shape. And if you're taking GIST, you'll learn a little bit more about how those projections work. So you can see we've got concepts of place and space moving forward through with a little more technology, a little more understanding of mathematics and astronomy, helping to make more precise maps. And then we start thinking a little bit more about how these different, all this information contained on a map can actually be layered on top of each other. So back in the day, you know, maybe 100 years ago or so, you would start seeing maps where different layers would be on onion paper, and they could actually layer things and see how different kinds of information interacted. But then computers came along, so that's when things really started to get fun and started to change, because then over a rather short period of time, it became clear that we could start to turn these layers of information into something that the computer could read and could process. And then fast forward to where we are today, and of course we have our massively powerful computers and mini computers, but we'll get to that later. To finish, so GIS, generally speaking, was invented by this guy, this British researcher, Dr. Roger Tomlinson, working for an aerial survey company, and he came up with this idea of combining geographic data with emerging computer technology and came up with the Canada Geographic Information System. And then in the 60s, these concepts made their way down to Harvard. They didn't have too far to go. Canada to Boston is not too far. Where Jack Dangermond was a student doing landscape design, I believe. And he kind of took that Canada Geographic Information System, tweaked it, and invented the basis of Esri ArcMap software, which we will be working with today. So this guy and Esri are located in California. They're in Redlands. They're not very far from here. And they're a pretty important company in the whole industry. And it's the software we'll be using during our class. So it's a rather new and still evolving way of mapping. So what makes a GIS? There's several features that go into it. Of course, we need powerful computers. As we start going along and doing our labs and learning more about what goes into a GIS, you'll realize that your computer is going to be taxed to the limit when it starts processing data. You'll see it runs a little slow, it takes a while to process stuff. So we need powerful computers, and we have powerful computers, especially compared to 10, 20, 30 years ago. But when it gets really powerful, when we are able to use enterprise and networks where we can really enhance the computing power of a system. We also have ever advancing software. So Esri, for example, is always updating ArcMap. It's always coming up with improvements. It's always changing what it can do. So it's not a static software system. It's actually always being updated and changing to suit the needs of the changing kind of data and the needs of the people who use it. Second or third in this list is massive amounts of geospatial data. So we live in an era where we are just generating and creating what I call big geospatial data. It's something you'll probably learn about a little bit more in GIST if you haven't already heard of it. And this is all generated through our smartphones and through our computers and just in all of the satellite imagery. So everything we do is creating this geospatial data, and it's so much, it's so profuse. And that's why we need our powerful computers. And then the fourth aspect to what makes GIS, which I think is critical, of course, is the human element, which can sometimes cause problems, but it also can make things work better. And it's what makes it's what drives the technology forward, because we're the ones who are out there living in the world, thinking about how to solve problems and how we can use this geospatial data, this advanced software, our powerful computers to help solve problems. And that to me is why it is so important. So how did we get all of this amazing geospatial and attribute data? Well, I kind of touched on that in the last slide when I talked about how we generate big geospatial data. But just to review some of the ways that we do get this data, let's start up here. We have satellites. So we have satellite imagery, another very key component to creating geospatial data. This creates raster data. I'll go into more detail about what that means in a moment. Down here we have Ned Flanders holding a field collection GPS unit, so you can go out into the field and you can collect data while you're walking around. This tripod here is actually a GPS receiver for a GPS unit, handheld GPS unit, which is what Ned Flanders is holding. Over here, this other tripod with the man behind it is surveyors using that's called a theodolite, and it can be connected to the GPS receiver, so you can help enhance the information they're looking at. And then we don't want to forget these two. We've got our handheld mobile smartphones, we have our navigation devices, and we have our personal computers. All of these have the personal computer in particular has an IP address that generates a specific location for all the stuff you do on your computer. So that creates geospatial data as well. And of course, up here we have a drone. So we're also generating more imagery through the increasing use of drones. So GIS applications. There are so many ways it gets used. I've just highlighted a few here. We have government uses it in all these ways. Utilities and communication, that's my sector. I use it for in the electricity sector. We look at how all of the power poles are connected, and that uses essentially a GIS format. Business uses it to analyze demographics. It uses to analyze spending patterns, to look at certain zip codes and what the income is, and you can make lots of business decisions based upon processing that information through your GIS. Transportation, of course, uses it. Public safety, it's really important for law enforcement and for emergency call taking, fire services, because one of the things we can do with GIS is actually map routes and get real-time data and how that impacts where services need to go and the routes they need to take. And of course, natural resources, forestry, agriculture, conservation, climate, weather, atmosphere, this is all can be processed through a GIS. So what are some GIS products? And by products, I mean, what can we produce with our GIS? And these are things we'll actually go through, if not this semester, then in advanced GIS. This one on the left, the sort of fan-shaped thing, this is called a viewshed analysis. So if you were to stand on that center point of the fan right there and look out, the red is what you couldn't see, and the spots where you can see through it to the map is where you could see. So it gives you an idea of what is visible from a given point. So it takes into account the terrain. This here in the middle is what LiDAR looks like when the information is presented to you in GIS. So LiDAR gives us kind of the outline or shape of everything that is on the ground and its height relative to the ground. And that's a really interesting product. So we'll be looking at that in advanced GIS. Over here on the right, we have network analysis. What these gray blobs are showing you is, I'm not sure exactly what the time is, but I'll just guesstimate. Say from that red dot, it is a 5-minute drive to the edge of that gray line, and then it would be a 20-minute drive to the edge of the lavender line. So if that makes sense. It shows you how long it takes to get out of a certain area. This is watershed, this rainbow color here. And then this is a route calculator feature. It shows you the best route to walk based upon terrain and land cover type. And again, run through the GIS. And over here are more simple examples of a point buffer and a line buffer to show, say, for instance, 50 feet. A 50 feet circular buffer around a point would look like that. Or a 1 mile buffer extending out from this line. If, say, if this was a street, this would be 1 mile away from that street on either side. Okay, so some things we can do. The simple stuff down on the left is what we'll be touching on more in this class. So I wanted to show you an example of some big data and how it gets used, just to see how something that can get mapped very quickly. A few years ago, there were some bombings in Paris, and right away people started hashtagging on Twitter. I think it was the Charlie Hebdo attacks. So using that hashtag, this person was able to process the way the peak and the flow of how people around the globe started to hear about the attacks and started to tweet about it. So, oh, I actually can't play it in here. I thought I could. Slide 14 to 20. Well, I will skip that one. I can't figure out how to get back to it. So before we get started, actually, I'll put the link online because it's a really cool graphic to look at. So I'll put that up there so you can watch it yourself. It's like 20 seconds long. So before we get started, just wanted to say, why ArcMap? Why Esri? Well, it's the leader in the industry, and it's what a lot of places use for work. If you're working with GIS in the workplace, it's probably going to be ArcMap. So it's good to get started with it. There are other versions of it, GRASS, QGIS, and even capabilities within Google Earth approximate what Esri does. So there are ways to do it in other formats. There are lots of products that are associated with ArcMap, ArcCatalog, ArcMap, Scene, Globe, and Python. But there's even more, and this can all be explored on the ArcMap website. So let's talk briefly about the basic components of working in ArcMap. So this isn't not even getting into the software itself. What you need to have in place is a known coordinate system. So this is how the computer knows how to locate and visualize the geospatial data. And the known coordinate system can be either a geographic coordinate system or a projected coordinate system. We'll be going over more of that as we move through the chapters, and we'll visit that some in GIST. But just know that this is a vital component to actually visualizing your data on a map. Next is the geospatial data. So it's the object, place, or phenomenon with a known location. So in this case, we have the vector data, the point, line, or polygon, and the raster data, which is an image that is broken up into little squares. And then associated with that is the tabular or attribute data, also the non-geospatial data. So again, it's the data that describes what's contained in these little points and lines and polygons and in the rasters. So let's talk about geospatial data more specifically. I just mentioned on the last slide, vector data consists of points, lines, and polygons. People will also refer to it generally as the geometry of something. So everything that's a vector data will be, sorry, I had to pause the presentation to plug in my computer, sorry. So yes, vector data, points, lines, and polygons. This can be text, nominal, ordinal, interval, or ratio data. It's all visible on an attribute table, so don't forget about that attribute table. Then we have our raster data. This is the continuous data that I was talking about. It's called continuous because you show a continuous phenomenon across a surface. So we're not just talking about discrete points over here like a house or a sector or the county border or something. Over here we're looking at like images of landscapes, images of topography, things that go over a large area, and they're divided just for organizational purposes into small squares in the photograph, and those squares have assigned color values. get into that more later. That's called raster data. So these two kinds of layers, both vector and raster data, they're movable, analyzable, changeable, both visually and mathematically. These can be layered, such as this, inside of your map that you're creating in ArcMap. All of this gets stored in what's called a geodatabase. And a geodatabase is where we contain files such as feature class, feature dataset, shapefiles, and other non-geospatial data, such as tabular data in Excel format, photos, and stuff like that. So have those basic foundational things in place. Let's talk a bit about the interface with data view and map view. So once you open up ArcMap, the things you're always going to be seeing are the table of contents, which is here on the left, the catalog, which is over on the right, and you have the toolbar up above, which you can add and subtract toolbars to, and then you have the map document in the middle, which is where you can actually see the visualizations of what it is you're doing. Also note that the files when you work in them and save them, the extension is called MXD. It's a map document, and an MXD is one important distinction to note about saving a map file is that it does not actually save the data that you're using to make the map. It's saving a reference to the data. So you'll have the image there, you'll have the reference saved in your table of contents, but the data is not actually there. It's actually in your Arc catalog. We'll get into that distinction a little bit later, but just know that there is a difference there. I just wanted to give you a brief on what's up with all these files, because when you open up a shapefile or a geometry file if you were to open it up in your normal browser on your computer, it would look like this. There's a bunch of gobbledygook, and you'd be like, and there's like, looks like hundreds and hundreds associated with one file. Whereas if you were to open it up in Arc Catalog, it'll look like this. It'll be these 5 little files here. This is just to say that you have to open up these files in Arc Catalog or ArcMap, or else they won't make any sense, which also should mean don't touch these files. So if you open this up in your normal file browser, don't erase anything because it'll mess up these files. So just leave those alone. Only work with them in Arc Catalog. And one last thing, going into this, as you start working in ArcMap, remember that the right click is your friend. If you push on if you select something in ArcMap anywhere and you right click, you're gonna come up with more options. And I always find it's the default where I'm like, oh man, what do I do again? Where do I go? I forgot how to do this. Just move around, right click things, see what the additional options are for navigating, and it'll help you move through it. I mean, I remember when I was first learning GIS, I was always like, oh yeah, right click. That's how I get there. That's how I get there. So, you know, as you're getting through this and getting used to it, just remember to right click.